Good morning, everyone. Welcome to another episode of Xah Talk Show. We're gonna code Wolfram language. I'm gonna show you some Wolfram language functions that does combinatorics. Wolfram language functions doing combinatorics. Okay. So if you are watching this offline, play at 1.5 speed because I ramble. If you are watching live, say hi in the comments. Hi Tao. So Wolfram language, let's Wolfram language tutorial. So you can go there and check out the full tutorial for programmers, and you can also download Wolfram language for free. And okay, so let's begin. So let's begin. So here is Wolfram language. Copy the file path. Here's today's talk show. Paste the link there. Linkify showing browser and go there. And what we want to do is several functions on list that generates combinatorial things such as permutation. Given a list of items, you want to find all possible arrangements. So that's one of the problems. So let's go to there. So list data structure association. So let's go to list operations. So list operations combinatorics. So I'm gonna show you. Okay, you will see in a moment. So first of all, paste the link here. Paste link file so we can go there directly. So there are several functions. This is amazing, fantastic. Try to do this in Python, JavaScript, or Golang, or whatever your favorite language, Rust, Haskell, or Camel, or F#. Try them. Usually they are not built in, but Wolfram language has them built in. Okay, so let me just show you a couple because there are several. You see, what I want to do is I want to add the groupings and subsequence. But let me show you. So generate tuples, all possible tuples. Okay, so Wolfram language for programmers. So combinatorics, update today's state here and tuples. Okay, go to pre. So here's tuples. So you want, given a list 1, 2, 3. You want all possible 2 tuples. So that's how you do it. Run it. Okay, so here's the result. It's all possible pairs of these 3 items. You see, 1, 2, 3. You see, so that's the output. So let's try. You can also try A, B. Let's say A and B symbolic, and let's say all possible 3 tuples. Run it. You see, you got AAA, AAB, ABA, ABB, BAA, BAB, BBA, and BBB. Fantastic and beautiful. Okay, showing browser. So that's tuples. And what if you want, there's variations. You see, one, let me show you. Okay, so it's also about tuples, but variation. So what if you have 2 lists? The first list is 1, 2, 3. The second list is A, B. You want all possible pairings. Again, the result are tuples. So run it. You see, 1A, 1B, 2A, 2B. So that's another alternative argument form for tuples. Okay, showing browser. So Wolfram language has the property given a function. Function is usually named based on the result. So if you have a tuples, a function named tuples, that means the result are tuples. Okay, then so one of the most basic usage is tuples of a list of items. Then you specify how many tuples, n tuples. 2 items or 3 items per tuple, 3 tuple. Then you can also have a variation. You given a list of lists. So basically, what this does is called Cartesian product. So it forms a tuple And the first part is whatever possible elements in your first list. The second part is whatever elements in your second list, and so on. So if you give a total of 3 lists, then the results are 3 tuple. You see, so both are tuples, but they are different. So, but they are all named tuples because that's what they are. So Wolfram language has the property applies to all functions. The function name indicates the result, okay? Like different programming language, they have different mechanism, different philosophy about how they name their functions. For example, in PowerShell, okay, so in PowerShell, they tend to name, for example, let me show you, okay? So close that, start a new PowerShell, and magnify, okay, and child, CHIR, what? What's going on? Oh, get child item. You see, that's a name. You see, in PowerShell, all command names are named like that, something dash something. So the first word is a verb. The second word describe what the is a noun, describe what the verb do too. Okay, so in PowerShell, all commands names are named like that. So what I'm saying is that different programming languages, they have different way, kind of systematic way to name their functions or commands. So let's go to PowerShell. So you can see a complete list PowerShell tutorial. Check it out. That's my tutorial on xahlee.info. Okay, so download and install a list of aliases. For example, here is a list of all aliases, and here you can see kind of all the possible command names. Where dash object, for each object, add content, get content, set location, clear content, clear host, clear history, clear item property, and clear variable, and so on. And move item, move PS drive, move item property, move alias, move module, and new, so that's the naming of a PowerShell. Now in Wolfram language, so the function name typically describes what is the result. Okay, so here is tuple that gives all possible tuples. Now that's one thing. Okay, the naming of the let's write it down. Okay, naming of programming language names. Okay, so I was working on the Lojban artificial constructed language. So copy that. So what are we here? List combinations. So talk show. So we talked about PowerShell and naming of functions in different programming languages. Okay, that's an interesting thing to dive into. So you can look at Python, C, C++, Java, whatever your favorite language. Some of that language may not have consistent names, such as the Unix fuck. Everything in Unix. Well, you can say they are consistent because nothing makes sense. They prefer the briefs. They prefer, CD, CD, ls, cat, grep, nonsensical, juvenile. That's what Unix is. By the way, something interesting, let me tell you guys. So a friend visited me, Discord. We met on Discord, and so Kim Possum and Xah. Okay, Possum and Mickey Mouse. So yeah, we were talking about naming of things, naming of functions in different programming languages. And what was it I wanted to say? There is some. I forgot what to say. I forgot what is the thing I wanted to mention. Anyway, so a friend visited me, naming. Let me think. Okay, naming a function in different programming languages. So you got Unix. Okay, yeah. So here, so I wanted to show you. He went to the computer museum, which is kind of the famous tourist spot in Silicon Valley here, Mountain View, where Google is at. That's where I live. Okay, Google is like 30 minutes walk. So. And we have a computer museum. You can look up, computer museum in Silicon Valley. So they show this Unix operating system, and they call it Universal Operating System. What a farce! What a fake story! Unix. Why is it named Unix, like UNIX? That is because it's a pun by these hacker types. We hackers love puns and fuck, and we don't mind, saying those swearing words. Sucks, fuck, and whatever shit. So Unix, the name Unix, it was a pun against Multics, MULTICX, which is a operating system popular at the time, 1970s, I think. So why do they name it Unix? Because it's like eunuchs, the guy without penis being cut off. Unix, kind of offensive term, offensive and ugly and juvenile joke. That is the root of Unix. The Unix type of people, they love that. So why is it named Unix? Because the eunuchs, against making fun of Multics. But now, in the computer museum, they say a universal operating system. I never heard of that phrase. In my 30, 40 years of reading about Unix history, I never heard of this phrase, a universal operating system. What the fuck? So this is how history become twisted. Like when you read back history 100 years ago, World War II, certain country or whatever, they become all twisted. So here is an example about computing history from the computer museum. Okay, so that's what I want to mention. So we were talking about naming of functions in programming languages. Okay, so some of the programming language, they do follow a consistent naming, such as Wolfram Language, such as PowerShell. You may not like their philosophy. Each one is different, but at least they are consistent. Okay, Bash, consistent? No. Unix, it's fuck. It's full bar, fucking fuck, or fucked up fuck. That's what Unix is, which became Linux. So this is an example of my deep hatred against Unix and C. Okay, so anyway, let's go back to the combinatorics. So we demonstrated tuple, actually just 2 cases. Then there's more cases. So here's another example of tuple. Okay, let me show you. Okay, so we illustrated. So go to Wolfram Language, Combinatorics. Actually, let me write down the naming of functions in different languages, okay? Different programming languages may have, may have different philosophy of naming of their functions or commands. Some programming languages has a consistent philosophy. For example, PowerShell, Wolfram Language, and Emacs Lisp, and Lisp in general, okay? and and Java. Okay, I can say for sure Java is also consistently named. Doesn't matter you like it. So whether you like their philosophy of naming is one thing. Okay, but however they are consistently named. Okay, these are some examples. But some programming languages do not have consistent naming scheme. For example, Bash, Unix tools, and does it apply to C? Yeah, kind of. Okay, C and C++. The sickest fuck. Anyway. Okay, so anyway, let's make that. So that's about that. Okay, that's one topic. Now let's go back to tuple. So we were doing demonstration of tuple. Let's show another example of tuple. Okay, so actually I need to rewrite this part. Okay, so here's original. Now we're gonna say because I was so what I'm doing now is improve the writing. So right now it says tuple given a list and given a list of numbers, return all possible array of dimension n1, n2 something using elements in list. Okay, that's the current wording, but let me reword it because it would be better. Okay, return all higher dimensional array of return all, let's just say this, n by n2 by that array. Okay, showing browser. So the new version says return all n1 by n2 by act array using elements in list one. So I think this one is more clear. So this is about technical writing. Whether so I think this one is clear. Okay, but I have to think about it actually. But for now, let's leave it. So let's demonstrate this one. Okay. Comments and questions, 14 people. I got a crowd. Wow, a lot of people saying things. Okay, let me read it in a bit. So here we want a 2x2 array. Okay, and their elements is A or B. So we want all possible 2x2 array with elements A or B. Okay, let's try that. Okay, so so then you need to format it. But basically what you get is this. Okay, so each one, so let's see. So you see each one of these is a 2x2 array. AA, 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 AB, AA, BA, AA, BB, AA, AB, AA, AB, 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 BA. You see? So if you say 3, let's try it again. Okay, so let's 2x3 array. Okay, now that's gonna be more huge. It's gonna be the length of search is gonna grow exponentially. So you got all these. Okay, now what if you want to format it? I don't have that feature in Xah Wolfram mod. So let's start Wolfram language. Then you'll format it well. Okay, new notebook, and place a notebook here. And let's say 3, shift enter to start the kernel, and let's magnify 150. Okay, then we want to do tuples 2, 3. Okay, paste it, shift enter. So you see it looks much better. So you see automatic formatting, see, on the fly. And if you want, and you can say matrix form, and you can actually format it by, let's say, matrix form. So it kind of make it nicer. Wait, or you can also say this is super long. Let's say table form. Okay, table form table form is boring, and you can say tree form too. Oh, this is humongous tree. This shows a tree, but it's humongous. You see, so we got a giant list and sublist and sublist. Okay. So anyway, that's demonstration of tuples. Okay. So and you can also have more elements. You know, A, B, and C. Let's say 1 by 3 array. Okay. Run it. Okay. So you got that. And let's see, 1 by 3. So 1 by 3 is simply a vector. So each one of these is a vector. Okay, so that's a demonstration. So you see, so this form tuples, you want the first argument specifies a list of elements you want to be as the tuples elements. The second argument specifies a dimension. So here means 1 by 3. And here is 2 by 2. Then it generates all possible such dimensional arrays. So in this sense, this array, n by n, n by m array is actually a generalized version of the sense tuple. You see, normally, okay, I need to adjust this should be. You see, normally a tuple means just a flat list of n items. 2 tuple is a list of 2 items. 3 tuple is a list of 3 items, right? But here, what you have is basically higher dimensional tuples. So tuple is basically an array. Tuple is basically one-dimensional array. Or in other words, a tuple is just a vector. Okay, so a general sense of tuple is n by n array, or n by n by n, by A by B by C by D, higher dimensional array. So what I'm saying is that Wolfram language, first of all, the naming convention is that the name of a function means the return result. It's a noun. It's usually always a noun. It's just what what the return value is. So those are tuples. That's one thing, naming convention. The other thing is that Wolfram language, for each function, they extend all possible things about tuple. So you can specify a tuple of given list of elements, or you can specify several lists of elements, where you generate a tuple by taking element from each list, Cartesian product, or you can have all possible higher dimensional tuple, which is array. So that's about tuples. Okay. So let's clean up. Let's return the code to what I had. Okay. So we don't want that. Okay. So syntax clear. So we talked about tuples. Then there's subsets. Again, just like tuple, but different from tuple, this is talking about subsets. So let's show one example. Okay, so subset 1, 2, 3 gives you all possible subset. Empty set is a subset. 1 by itself is a subset. 2 by itself. Okay, 3 by itself. Or you have a subset of 1 and 2. Or 1 and 3, or 2 and 3, or the whole thing 1, 2, 3. You see, that's subset. Of course, you can change, the value to whatever. So those are subsets, you see. And here, when we are talking about subsets, the order doesn't matter. So you have an item of 1, 3. You have an item of 1, 2, but you do not have an item of 2, 1. Because they are considered the same. We are talking about sets. which is different from tuples. Okay, so here is how you generate all possible subsets. Okay, so now let's return to whatever I had. Okay, then there's many variations. You can specify subset of 2 items only. So you want maximum. Okay, so you can specify maximum length of the subset. So in this example, you don't have 1, 2, 3. Or you can specify the subset such that each subset must just have exactly 2 items. So then all you get is 1, 2, 1, 3, 2, 3. Okay, and this is still different from tuples, because if you generate all possible tuples, you would have 1, 2 and 2, 1. Right, but you don't have that here. So anyway, so these kind of problems, generate all possible things. They are called combinatorics. That's a branch of mathematics. Okay, in other words, it's a counting problem. Technically it's trivial because you can actually just count them. Like a child. You write down all possible 0 items or possible 1 item, compare. But it gets quickly it becomes impossible because it's too it'll take you 1 million years to finish it. So that is why you have the mathematics of combinatorics. That's kind of finding efficient ways to count things, sometimes without even actually counting and listing them. It's a broad field of mathematics. Okay, so for example, in graph theory, lots of problems in graph theory in combinatorics, or the lottery. If you buy a lottery, what are the chances you're gonna win? That's probability, right? But in order to do probability for this problem, you need combinatorics, because you need to know all possible combinations of 6 numbers out of 49 something. So combinatorics is a branch. Okay, so let's put this back. So subsets. So we covered tuples, we covered some example of subsets. There's more variations. Then permutations is interesting because let me show you. So let's just do it here in Wolfram language. Okay, let's delete this humongous output. Okay, so let's just select all, Control A, delete all. Okay, now let's just do the permutations. So permutation of 3 things. So you got ABC, ACB, BAC, BCA, CAB, CBA. Okay, that's permutations. That's another combinatorics. Then you got variations. Then you got groupings and sequences. Okay, that is what I want to do myself because I'm writing a tutorial. I don't have coverage of that. So let's write them and demonstrate. Okay. So here is now Emacs workflow. Okay, so delete that. So let's copy that. Delete. Delete. Okay, so groupings. How do I want them? Okay, so what you have to do is do that. Okay, then subsequence is a function name that gives you a list, a definition list. Okay, so you want to turn that to code brackets, and you also want to turn that to code bracket refresh. That gets you that. Then of course the references you gotta move. Remove the list. Okay, then cut. So here is a reference for sequences, subsequences, all possible subsequences, and here is a reference for all possible groupings. Okay, now let's demonstrate groupings. Okay, so start a Wolfram language code, and let's just pop it out. Grouping. Okay, so let's see 1, 2, 3. So given a list, it will show you all possible, like if you're gonna put parentheses. For example, if you're gonna put parentheses inside the list, that's one grouping. So basically, you want all possible groupings. Okay. So let's undo. Okay, redo, run it. Code with argument 2 or 3 expected. Okay, so you want, let's see, the documentation, groupings. Okay, K, taken K at a time. Yeah, so this is actually the lottery. The chances to compute the what's your chances of winning a lottery. Groupings gives a list of all possible groupings 1 to n, taken n at a time. Okay, so let's rewrite that. What? Oh god, Windows key, Control key off. So that's an issue about sticky keys. Okay, so groupings, let's say 3, 2. So 3 items taking 2 at a time. Run it. Okay, so this 3 item means 1, 2, 3. So a list of 1, 2, 3, then 2 at a time. Grouping 2 at a time. Run it. Yeah, so that's identical. So this 3 is just the shorthand of generating this list. Okay, this list. So that is the basic idea. So we just covered that and that. Then you can have combination of all possible groupings of each of the list A, B taken K at a time. So I'm not sure what is that. Let's try it. Okay, so comment out, remove that, copy that. 1, 2, 3, and let's say A, B, C. Okay, taken 2 at a time. Run it. Invalid arity specification. What is that? Oh, the first argument, they should be together. Okay, they should be one list. Okay, run it. So we got 1, 2, then 3, then A, B, then C, and 1, 2, 3, and A. So how does this work? Taking 2 numbers. Okay, so you want to group 2 elements. So that's what this 2 means. Group 2 elements, so actually this is just equals to, this is actually just equals to combination of these 2, I think. Am I right? I mean, combining these 2 results. So I think, let's see, 1, 2, and 3, 1 and 2, 3 there, yeah. A, B, and C, yeah. So this is just the shorthand of these 2 together. Okay, anyway, that's some basic about grouping, showing browser. So I need to permutation, so I need to groupings, I need to write a description and read the documentation more in detail. It can get fairly complicated. Okay, so next item is subsequences. That's very interesting. So let me show you. So subsequence. So let's Wolfram language. Subsequence, subsequence, that's right. And let's say just 1, 2, 3. Okay, run it. Okay, you see, now it's about subsequences. You see, so you given a list, that's a sequence, then you want all possible subsequences. So empty sequence is a subsequence. Now the sequence just just a one number. 1 is a subsequence. So is 2, so is 3. Then you got 1, 2 as a subsequence. Then 2, 3 a subsequence. Then 1, 2, 3. However, you don't have 1, 3. You see, you don't have 1, 3 there. So you see, so this is different from tuples and also different from subset we showed before. So that's an example. Syntax color showing browser. I think that's it for today. So when I'm offline, I'm gonna read in detail, see all the variations and document it here. So today this is about list operations. Now you can try to write any of these in Python, Golang, JavaScript, whatever your favorite language. Usually, like all of these, like except 1 or 2, most of them are not in other languages. So you have to write them yourself, and it's not trivial. Okay, this is simple problem. You can do it in like 10 minutes to an hour. If you are a professional coder, you can write it in 5 minutes. Or if you are new, you can write it in 1 hour. But however, when it comes to efficiency, you run into problems because you need to write your code to generate all these possible combinations in an efficient manner, speed and memory consumption. If you take those into account, if you want to really write a program that's really efficient, then it becomes like it'll take you several days, something like that. And also, if you want to create one single function that does all these variations, so it's not trivial. So it's not trivial at all. Okay, so let me read the comments. I think that's it for today. That's 48 minutes. That's about 40 minutes. 5.9 gigabyte download, Wolfram Language. Oh, okay. It's also asking for a license. Well, you go to, you just follow their instructions. Don't do any tricky stuff, don't create a new email for whatever, then you'll have it. I don't know what, it's asking, you can do it. I don't remember exactly what's the procedure. Actually, have I ever installed the free version? I don't think I have. ACP says, I went to the computer museum once and I saw Nintendo Saga on display. Nintendo and Sega. That's nice. Yeah, well, they are warranted. Computing became popular in last 40 years or so. So this Linux and UNIX is just beginning. Other countries are realizing the power of these technologies. It is only a matter of time when other people develop something far more superior, okay, seriously though. Am I missing something if I exclusively use evil mod? I could go back to default bindings if that's the case. So I don't remember what is the context, but evil mod for Emacs is pretty good, okay? But if you want to upgrade, you want to be more efficient, then I recommend xahlee keys, okay? Which, Pranshu, are you the Pranshu guy? Palash backup. So xahlee keys, I don't know if you watch my video, so let me show. So xahlee keys, I talked about a few days ago. There's an episode on latest version and lots of demo, and I have like tens of videos about xahlee keys. So it's the most efficient key binding system for Emacs and more efficient than Vim. Okay, more efficient than if you actually use Vim. God mod is no good. Okay, I can recommend. These are old stories. God mod has been around since 15 years ago, and of course I know it well. God mod is no good. Okay, I do not recommend it at all. So ACP says most of my professional experience has been with web apps and big data apps. So while Wolfram language very powerful, I am ignorant about its application in business world. Wolfram language in business world not much. Okay, I think there are some in financial world and in business world, but they are, well, there's, Wolfram language is mostly for scientific programming. Or if you are a hobbyist, you want one programming language that does everything possible, which is actually the Lisp philosophy 30 years ago. Lisp is of the philosophy that one language to rule them all, so you have like all possible functions. Wolfram language is like just one mega level up, so you can do anything: physics, chemistry, mechanical engineering, electronic engineering, anything, algorithms possible. If it's possible to build in, if it's a known algorithm, it's already built in. Okay, if it's a known concept such as machine learning, such as statistics, such as probability, combinatorics, list processing, text processing, artificial intelligence, neural networks, modeling of physics, fluid dynamics, if it's possible, possibly done by computer, it is in Wolfram language built in usually by just one function. Okay, so you can, in some sense, you can think of it as the God's calculator. Okay, you don't have to, I'm gonna download Python, you need this library, that, or npm, then what does this library do? Oh, it's got a bug, so you have to use that library, you need to update the version, like a mess. So Wolfram language, one single package, coherent to do it all. And it is mostly used by engineers, scientists, mathematicians, physicists, mostly. Okay, but they today and computer scientists. Okay, for example, Donald Knuth uses Wolfram language long time, and he also uses Emacs and Wolfram language, and quite a few several prominent computer scientists. Okay, that's it for today. Bye, guys. So if you like my stuff, donate to me. Okay, go to xahlee.info. Go to the bottom. If you have a job, donate to me $100. Okay, Patreon me, Amazon gift card me, PayPal me. That's it. Copy that. We shut down in a minute. Okay, so let's just paste stuff here. Bye, guys.